Okay, so today we will see a very important topic from class 12th biology, that is chapter 13, organisms and population. So in this chapter, a very important topic which is exponential growth of population. It comes under the population growth topic, under the subtopic exponential growth. So we could easily see that the graph for exponential growth of population goes like this. So this curve is known as J curve. Or as we can easily conclude from the curve that it's an exponential growth. So this curve is also known as exponential curve. Okay, right. So this is J curve or exponential curve, or sometimes it may also be known as, you could easily see that this has a shape not obvious to see, but we can call it as C curve. But it's not a C curve. We rarely use this term. Let me select one. So this is usually J curve or exponential curve. But the question here is this: when we come through this topic, which is exponential growth, we had a formula in the biology book, written NCERT biology book, written as dn by dt. I'm sorry, it's not dn by dt, it's dn dt, or ddt of n goes like r into n, where this dn dt is the rate of change of number of population, r is a constant, and n is the number of people, number of persons. Okay, so firstly the biology book tells us that dn dt is proportional to n. It's quite obvious that the rate of change of population obviously linearly depends on or directly proportional to the number of persons. And to remove this proportionality sign, here we use a constant. Which is r, and this r is called intrinsic rate of natural increase. And it has some very important value in this equation. Okay, so this is not the problem. The problem arises when we see the curve. We see the curve as an exponential curve, like this. This is exponential curve. The problem here arises that as we can see, this equation is not an exponential equation. Let me minimize myself. Okay. So this equation doesn't seems like it has an exponential component anywhere in this equation, right? Okay, I hope you can see the screen, because the stuffs written on the screen is more important than seeing my face. Okay, so what to do? So the NCERT doesn't covers how exponential equation is coming from this equation. So let us use some mathematics and physics to understand how this exponential curve comes from this very equation. Clear? Okay, let's see. So firstly we have to do some mathematical manipulations to this equation. Let me start from the beginning. The equation, wait a minute. The equation is like this: dn dt is equals to some constant r into n. Okay, so we have to do some mathematical manipulations like dn, and we have to bring this n under dn by n is equals to r as it was there, keep it as it is, and we need to bring this dt beside this small r. Okay, and then we have to apply a integration on the both side, and since r is a constant, it will come outside of the integration, so we need not take an integration outside r, rather we can put the integration sign here as r is a constant. Okay, so we know that dn by n, when we integrate this, it becomes ln n, and r, and when we integrate t, it becomes, when we integrate dt, it becomes t. Okay, and this ln n, if we take the ln on the other side, it will give you e to the power rt. This is simply the law of integration, just to integrate. Okay, so this was just a mathematical manipulation. And also, if you see the NCERT book, here is some constant n naught, how it comes. So let me illustrate that too. We have to put a limit, we have to use a definite integral. So in place of indefinite integral, we have to put some limit to make it a definite integral. That means here n naught to nt, wait, let me use another color. Okay, n naught to nt, and for the integration over dt, we have to use time 0 to t, from time initially 0 to some time, to some instant of time t. Okay, now let us integrate in the same fashion as we did. This thing becomes ln n, and due to the presence of the limits, here we have to put n naught and nt, from a initial number n naught to a final number nt, from a initial number n naught at some final number nt. Or we can also say that this, at time 0, the number of individuals was n0, and at time t, the number of individual is becoming nt. Clear? Okay, at time 0, the population is, or the number of individual is n0, and at some instant t, after some time, the number of individual becomes nt. Okay, great. So on the right hand side, as usual, we did t, but due to the presence of limit, we will put 0 here as the lower limit and t as the upper limit. And as we do, we have to put the upper limit first at the place of n, that is ln nt first, then we have to put a minus sign, and then ln n naught, and in the right hand side, r t minus 0, and t minus 0 is simply t, so I'm sorry. Okay, so if we take the ln, this is ln a minus ln b, and here we go, as the formula says, ln a minus ln t is ln a minus ln b is ln a by b is equals to rt, and if we take ln the other side, it becomes nt by n naught is equals to e to the power r into t. And here you can easily say that at the other step, nt will be equal to, the n naught will go that side beside exponential, so nt will be equal to n naught e to the power rt, and here we see that the formula has came. So that's the steps which the NCERT has didn't discussed with us, so here it is, right? So let me write the final formula. I hope this is clear to you. Okay, the final formula becomes nt is equals to n naught e to the power rt. So now in this formula we can see that exponent term is here, and now we can put a graph showing t as in the x-axis and showing the population density in the y-axis. And what's the relation between them? They are directly proportional or exponentially proportional. So we can take an exponential curve like this, and yeah, this is it. Okay, thank you.